In previous videos in this series, we discussed the technical elements of IoT, such as sensors, actors, devices, machines, and gateways. We also mentioned the benefits of IoT from a variety of perspectives. In this video, we are going to look into what a typical data flow in an IoT solution looks like. Let's think of a case where a company transports frozen supplies to several locations. The company's trucks are equipped with sensors that report their GPS location, the supplies they have loaded, and the temperature of the load. There are also actors which have the task of controlling the temperature. This data is provided in a pretty raw format. There is also an IoT gateway that is capable of communicating with the sensors and actors. This gateway could be located in the cloud, but is inside the truck in our example. Given the huge amount of data collected by the sensors, the gateway collects this data, reduces it to the amount required for the business, and sends out the data in the form of messages. With a mobile connection, the data is transmitted to a cloud-based message broker via an internet connection. The data is given a timestamp here and is forwarded to its correct destination. In our example, this is a cloud-based data lake which collects a large amount of different messages. Of course, different deployment options are possible too, where other elements are used in the cloud, or maybe none are used at all. Regardless of the deployment options, the data will end up in a business system, where it can be combined with existing business data like transactional data and master data. It's interesting to note here that a typical IoT solution includes additional data provisioning. One example of this data is the metadata of the sensors. This indicates the type of sensor, its physical address, and its location or data format. Another example could be the definition of business rules and actions that can be applied to things. Here, for instance, we could think of a rule that causes the freezer to be cooled if the temperature exceeds -7 degrees Celsius. These rules and actions can provide a relevant environment to enable the business systems to autonomously act and control actors. In our example, the business system might regulate the temperature based on the items that are loaded in the truck. Another path we could follow in our use case is where specific applications support the analysis and monitoring of the given data. Users who are empowered by these applications can initiate actions based on a much more comprehensive insight. We can imagine a user, for example, who identifies a repeating pattern in the historical data, which helps him to optimize activities. As a result, this user might then change the current state of an actor. Coming back to our example with the truck, let's think of what might happen if the temperature of the load increases, thus heightening the risk of an interrupted cool chain for the load. Based on the sensor data and the rules in the business solution, the system automatically recalculates the route of the truck, preferring closer locations instead. This is proposed to the dispatcher, who could send this new route to the truck driver. Another possibility is to automate this step so that the truck driver is given the new route directly without the involvement of a dispatcher. Of course, there are endless possibilities for improving a situation like this. And the great thing with IoT is that endless solutions are imaginable. By the way, the picture here hints at another interesting aspect, as the message broker seems to play quite a significant part here. We will get back to this in more detail in another video.